Okay, so there are a few important things about exponential that we have to take notes of. Do you still remember the important one? Okay, so that is, I know that e to the power of anything, the value is always greater than 0. That's the first thing. Second thing, okay, can you all hear me?
Yeah.
Okay. Okay. Okay, second thing, today my internet is not very stable. Okay, second thing is talking about the domain of the exponential. Okay. Yeah, so I'm going to do the first part A. I don't know why it doesn't, my Apple Pencil doesn't work. Okay, I will try again. Okay, so I can't change the color. So to find the x-intercept, or the y-intercept, so we will do it step by step. So we say when y equal to 0, that is, I put my fx equal to 0. I have my e to the power of 0.5x minus 4 equal to 0. So my e to the power of 0.5x will be equal to 4. Yeah. And still remember, when we change exponential to ln, make sure the left-hand side is one term, the right-hand side is only a single term. And since the right-hand side is positive, so there is a solution. If the right-hand side is negative for this case, then there is no solution because of this. Yeah, because of, yeah. Are you clear? Okay, so I say 0.5x equal to log to the base e, we write as ln 4. So this is the exact value of ln 4. If you use your calculator, you get ln 4, you get 1 point something. That is a approximate value. So 0.5 in max, 0.5 is half, right? So this will be x over 2 equal to ln 4. So therefore, my x-intercept, I can call this x as x-intercept because the y coordinate is equal to 0. So it's 2 ln 4. So this is exact value. So if you use your calculator and you type it out the value, you get approximately 2 point something. Yeah, that is approximate value. That's why I use this approximate sign. Okay. So when we want to find the y-intercept, okay, when x equal to 0, so my y will be equal to, or my f0 will be equal to e to the power of 0 minus 4. So all of us have to remember that e to the power of 0 is 1. 1 minus 4, I got -3. Yeah. Okay. Then for part B, when we want to find the equation of the horizontal asymptote, still remember, we have to study both direction, tends toward infinity or negative infinity. So we have to write as x tends toward infinity. So we have to study the first term first, that is e to the power of 0.5x. It will tend toward, Alicia? Is it possible for you to answer me? Alicia, it will tend toward? Alicia, can you hear me? Class, can you hear me?
Yeah, we can hear you.
Yeah. Okay. Yes. Alicia, is it possible for you to talk? E to the power 0.5x will tends toward what? Or will approach? I just randomly call you, okay? You try to give me the answer. Amir? Okay, Alicia texts to me. He said it will tends toward infinity. Okay, do you need me to explain why tends toward infinity? Class? Okay, I will explain once more. Okay, I can't change the color, so you just bear with me with the same color. I don't know what happened today. So e to the power infinity. So you have to put your x as infinity. So you ask yourself, okay, 0.5 times by a very big number. Oh. So is e to the power of, this is 2,000, 200. Is it very big? E to the power something that is very big. So this is very, very big. So these type of things you have to imagine by yourself. Okay, so you just put in a number and look at how the value go. Okay, so tends toward infinity. Are you okay? So this is something that you have to be initiative enough to do it. Okay, so now, is my fx e to the power 0.5x only? No. So my fx is e to the power of 0.5x, take away 4. So what will it tends to? Okay, 500, okay. So it will tends to what?
Infinity,
What will it tends
infinity
to?
minus 4.
Infinity minus 4. So in max, if you have infinity minus 4, so you will approach what?
Infinity.
Yeah, we will write as infinity. That means if I have a lot of money, I just give you 1 ringgit. So what so? It's still a lot of money. So it's infinity. So is there an upper boundary? No, it will go on and on. So here there is no horizontal asymptote in this direction. So as the graph go in a positive direction, as a graph go in a positive direction, then there is no, correct? So if you imagine as a graph. Okay. So now let's go study another direction. So these are something that you have to remember how to do. Okay, as x approaches negative infinity. So can anyone tell me what will happen to the value of 0.5 to the power of negative infinity? Yeah, Joshua, tell me that is very, very small. Anyone need me to explain why is it very, very small? So you will tend towards 0. Do I need to explain why is it tends towards 0? You please respond. If not, I will not explain because I've explained it before. I assume you know. Okay, so still the same way as we do for tends toward infinity. So you have to just take a value of negative infinity. Yeah, I take negative 1,000. So this one will be e to the power negative 500. And if we have power to the power of negative, what we should do if we want to imagine how big the value is, we have to put it in a fraction form. So this one will be 1 divided by very, very big. You can imagine if I take 1 divided by 100,000, what would the value be? It will be very, very very, very small, right? So in max, when the value is very, very small, we say tends towards 0. So now what happened to my this function fx? It will be e to the power 0.5x, take away 4. So you will tends toward, and you imagine this is 0. Okay, 0 take away 4. So it will tend toward -4. Okay, since here is take away, so you will take away 4. Yeah, something take away 4. So that means -4 is the lowest value. So the rest of the value of x will be more than -4. So this is our lower limit. So I can make a conclusion that the hold on. So the lowest value of fx is -4. So we write here, okay, from above, because this is the lowest limit. So you see, internet problem. I got some internet. Maybe it's unstable. So you just have to bear with me. Okay. So okay. The question is, do you need to show? Do you need to show in your exam how to get the horizontal asymptote? Yeah, the answer is a yes. And I know that there are some of you have a different way of showing it. Okay. The reason why I show this way is because this way is easier for people to comprehend. After I will show you another way of showing. Okay. So this is the lower limit. So now from here, I can make a conclusion. Therefore, the horizontal asymptote, I go to the next page because I cannot write below this line. I don't know what is the reason. Yeah. So therefore, I have the horizontal asymptote is y equal to -4. Yeah. Okay. I'm going to answer your friends say the working. Yeah. In the exam, definitely you have to show how you obtain it. If I just give you 1 mark, then you don't have to. But if I ask you to show algebraically, then you have to. Okay. Another way of showing it is like that. Okay. If I want to show this as whether got horizontal asymptote or not, I use a symbol called limit. So if you see I write this, it's harder to understand. So I write limit x tends toward infinity, my e to the power 0.5x minus 4. So this is my function. Okay, it will be equal to infinity. Okay, so there is no limit. So I will write down there is no limit. Okay, so limit x tends toward negative infinity, e to the power 0.5x minus 4 will be equal to negative 4. So you think which one is easier to comprehend? If I straight away teach you this by writing limit, so, and instead of showing you step by step, definitely this is the easier one for people who just start studying limit, correct? So it's the method that I show here. So when you talk about limit, actually this is another presentation of the answer. So if you think you are familiar with this method, you want to use this method to show there's nothing wrong. So actually this is something that we show step by step. You show step by step as like that, as x tends toward negative infinity. So this is the first step here. Then second step, we study this term. What happened to this term? Then I study the function as a whole. And we have to write from above. That means this is my lower limit. And here show you no upper limit. Are you clear? So when I sketch the graph will go in this way. -3 is your y-intercept. 2 ln 4 is your x-intercept. And the horizontal asymptote is y equal to -4. So the graph go this way. Are you okay?
Yep.
So that is how we work out the thing. So there is a lower limit. So this is called the lower limit. So all this skill is something that is new. So you have to take an effort to memorize how to do it. So this is the third one that we do. So a lot of math question, students find it difficult to do is because of what? You keep asking teacher for new question, yet the old one you haven't mastered it. So you see whether the two questions that we have discussed previously or this question, do you think is there any difference? The difference is just on the number. You see, the way of doing it is always the same. That's why I purposely ask you to do this question again before I get into another very fresh new thing to you. Okay, any further question? I continue. Okay, Noah, so everyone have mastered how the nature of exponential function look like. So exponential function, the question that we are going to ask you is two very important things. One is what?
Domain and range.
Yeah, the domain and range, the horizontal asymptote, and the x and the y-intercept, every function we will ask you. Am I right? So for this case, what is the domain? So the part C. So what is a domain? Usually for exponential, I told you already, right? Will I ask you for domain? I may, because some of my students may not know. So I may ask also. So the domain is this. Or if you don't like to write it in this form, you also can write the domain in this form, up to you. There are many ways of writing it. Correct? If you don't like this form, then there's another way of writing it. They put in a bracket form. Negative infinity, then they put a comma, infinity. Put a bracket. So there are many ways of writing it, so it's up to you. Same go with range. Okay, so in this case, what is the range? Range are the possible value for y. So if you look at this graph, and if you look at this is the lower limit, what does it tell you? That means it's telling me my fx, which is the y, is always greater than -4. So this is called the range. Am I right? So from here, I can straight away. So that is also one of the reasons for exponential function. We would like you to find the horizontal asymptote. If you know the horizontal asymptote, then you may be able to know the range. So I'm just giving you a simple one. So later in chapter 3, I may give you something that will involve some turning point. That one we will study later. So one step at a time. Yeah. So now my range is y. If you don't want to write y, you write fx. Okay. Y is a member of real number and y is greater than -4. Okay. So if I write it in this form, okay, what will I write is the range. I will write it as, so it's very careful. These are bracket. When you put a square bracket, okay, so what I will do is I will put a square bracket, negative, okay, sorry, let me erase this first. Okay, I will put a curve bracket to show that it is not equal to -4. You get me? So there is a difference. So the way you read it, all this, how to write a set of number, you can Google. They will tell you a different way to write a number in the set form. Yeah, this is in the set form. We use the curve bracket. Okay? Done?
Yeah. Yep.
Okay, so any further question? No, Okay, so now I want to get into another function. That is the inverse of natural log. Okay, that is the inverse of exponential. Okay, I'm going to start with a simple exponential function. Then I'm going to link it to the, what in my third domain is -8. I don't get you. What do you mean my third domain is -8? Okay, I have a few questions from your friend. The first one is, they say page 11 of the textbook. Okay, let's look at page 11 of the textbook. Let me settle all this first. Okay, page 11 of the textbook. Let's go to page 11. Page 11 of the textbook. Yeah. Go on. Example 1. Yeah. Okay. So if you look at the textbook, example 1, the way the textbook write, that's why it's not clear enough. You are not supposed to touch. If you look carefully, if you expect it doesn't touch y equal to 1. Okay, if you look at page 11 of the textbook, everyone look at page 11 of your textbook, the example 1. It's very good of you. Look at the textbook, example 1. You have to be very careful. Next time when you look at your quick calculator, also like that. So look. Every time when you sketch a graph, this is your y equal to 1. Definitely the graph will not touch y equal to 1. Your textbook do it in such a way that it goes very close. So when we sketch, we will try our best to show that it doesn't touch. Cannot. It approach, but it doesn't touch. Are you clear? So because the textbook, they get it from like they use technology. It is so close that you can't even distinguish whether it touch or not. Are you clear?
Yes.
So it doesn't, it definitely not. Okay, have I answered your question? Okay, another one said that what do you mean by third domain is negative 8? What do you mean by third domain is negative 8? Where on earth got third domain is negative 8? I'm talking about, sorry, this is the domain. Yes, why? Why is it negative A? If I write this, isn't it correct? From negative infinity to infinity. I'm just talking about here, the range also can be written in that way. Is there any issue on that? No? Okay, can I go? Okay, so can I go to the next? So please master this. This is a very important. In polynomial is not as important as exponential in year 12. Exponential is a very important function in year 12. Okay. Yeah, it's okay. As long as Mr. Dean disconnected, is fine. Okay, so we are going to talk about another function. We call it natural log. Okay, that is ln. Okay, y equal to e to the power x. This is exponential. Let me explain first before we get into that. So you have the x-intercept, y-intercept as 1, and there is no x-intercept for this case. So the graph go like that. Correct? Okay. Okay, so this is y equal to e to the power of x. Okay, so I have an inverse function. I try to change the color. It don't allow me to change, okay? So you just have to bear with me with the same color. So if I reflect this line, this function y equal to e to the power of x along the graph, along the line y equal to x, I will get this function. And this is 1. So for this function, it got horizontal asymptote. Yeah, for this function, it got vertical asymptote. Correct? So this function, we call it y equal to ln x. So the domain for this one is equal to x. X is a member of real number. The range for this one, I'm going to let you see the relationship. The range will be y y greater than 0. So if I have the natural log, then everything will be inverse. The domain here will be x. This one will become the domain. X is a member, x is greater than 0. And the range will be y. Y is a member or real number. It can be any number, you see or not? You go here and you go down here. So this is the relationship between the natural log and the exponential. The simplest, the simplest. So, and for this exponential, we have the y-intercept. For the natural log, we have the x-intercept. For this simple natural log and exponential function. So this is, there's no y-intercept, but there's an x-intercept. No y-intercept, but x-intercept is this is no y-intercept, but the x-intercept is, yes, got y-intercept, I'm sorry. Okay, there is a y-intercept. Why no one stop me though? Okay, y-intercept is 1, no x-intercept. So you see everything upside down. So that's why we call this, they are the inverse function. And you have to remember that if I have, how to change the ln to exponential, you remember? And okay, so I'm going to write down the formula, how to change exponential to ln to exponential, okay? So the only way you can do is if I have one term equal to a number, then I can find the x by changing it to this way. Okay? If I have only single long term equal to a number, then I can find this unknown x by turning it to e to the power a. Are you clear? So changing this is a very important thing to take notes also. Okay, any further question? Before I teach you how to find the domain range and so on about natural log function. Okay, okay, so we shall try one question on about natural log function, okay? Okay. So question, examples. The textbook example, I expect you to look through by yourself. Okay, given y equal to ln 5x minus 1. Okay. So usually the first question is we will say find the domain. Okay. For natural log, definitely I will ask you to find the domain. And there is a technique to find the domain. So you have to remember this fact that is, okay, very important facts. We know that for any long term, whatever in the long, must be more than 0. The reason is because e to the power of something is always more than 0. So that which means that if I, for example, okay, so ln anything. So whatever inside here, okay, it must be greater than 0. And knowing this fact will help us to find the domain. Are you okay? So very important fact. So I'm going to use this fact and find the domain. Shall we? So I know that whatever in the ln, so that is my 5x over 1 minus 1, must be greater than 0. Because if you don't believe me, you go to the calculator, you put ln -1. The calculator will tell you max error. It doesn't exist. Are you clear? So no answer. Okay, so then I solve for this inequality. So far, so good. Whoever can give me the answer. Okay, class, sorry, I got disconnected.
Yep, it's okay.
Yeah, sorry for that. Okay, I will continue. Can someone give me the function?
Y equal ln bracket 5x minus 1.
Okay, and I have got problem. I don't have the. I don't have my Apple Pencil sign. Can someone tell me what to do? Hold on. My Apple Pencil, the writing part is all out. Okay, never mind. We will continue the discussion tomorrow. We'll continue the discussion tomorrow, since also almost the time already, 4:48, because there's something wrong with my internet. Okay, so I will end here. I will continue tomorrow with this discussion. Can or not?
Yeah.
Okay, sorry
Yeah.
for the poor connection, because it's only left with another 3 minutes. Yeah. So you please master your exponential first. So tomorrow we will continue with our natural log. Yeah. Okay.
Okay,
Thank you,
Miss.
class.
Bye.
Bye.
Bye, Miss.
Yeah.